Okay, so we're going to look at the most missed problems from yesterday. The first one deals with density, and we know that density equals our mass over our volume. All right, so when I look at this one, it's asking for kilograms, so it's really asking for that mass piece of this formula. And we know that the density is 0.9, so we're going to put a 0.9 over here, equals mass, which we're trying to find, over the volume. Now, they tell us that this is a sphere, and the sphere has a radius of 9. So we're going to get 4/3 pi times 9 cubed down there for the volume. Now, if I take 9 cubed, all right, that gives me 729. If I multiply that by 4 and divide by 3, I'm at 972 pi. So I have 0.9 equals m over 972 pi. All right, I'm going to multiply over both sides by the 972 pi. All right, when I do that, I've got 972 times pi. All right, now here's where Khan Academy gets a little bit annoying. They didn't tell you to use 3.14, so they're expecting you to use the pi button on your calculator here. And this can lead to a mistake on this one. If you use the 3.14, you'll actually get 2747 as an answer, whereas if you actually use the pi button, you're at 2748.265 equals m. And that means that our mass to the nearest integer is going to be 2748. All right, so we're at 2,748 for the mass. All right, I hope that helps on the first one. Again, just remember that density equals mass over volume. That's a really easy way of kind of setting up the problems as you go through. All right, in the second one, it says Andy has a snowball, a perfect sphere with radius 3 centimeters. He wants the snowball to be bigger, so he spent 4 seconds packing more snow onto it. Each second he spent packing, the snowball's radius increased by 0.25 centimeters. All right, so if we're looking at this, it's 4 seconds, and we're doing 0.25 centimeters per second. So if I multiply those two together, if I have 4 times 0.25, that's a quarter of 4, or 1, and it would be 1 centimeter. All right, so over those 4 seconds, we had 1 centimeter. So initially, we're at 3 centimeters. After 1 second, we're at 4 centimeters. And this says, what is the ratio of the current volume to the new volume? So the current volume, this is a sphere, so we're at 4/3 pi r cubed. So 3, make sure that's the radius, yep, 3 cubed. And over here, we're at 4/3 pi 4 cubed. All right, so it wants old to new. All right, or sorry, the ratio of the current volume, the new volume, to the original volume. So current new compared to original. So 4/3 pi 4 cubed over 4/3 pi 3 cubed. The 4/3 pi cancel. I'm at 4 cubed over 3 cubed. 4 cubed is going to be 64. 3 cubed is 27. All right, and that does not reduce for us, so we're at that last one, which is D. All right, so D would be our correct answer. That was actually a commonly missed one on the homework set as well when we did density. When we did volume of a sphere. All right, moving on to the next one. We've got an empty cylinder is in the shape, an empty cup is in the shape of a cylinder. Pictured below is being filled with water. All right, the cup is filled at a constant rate, and the table below shows you how much. Now, what I notice here is every 3 seconds it goes up by 75, so that means we're really going up by 25 cubic centimeters per second. All right, that's our rate of increase in there. So this says find the percent of the cup that is filled with water after 7 seconds. So at 6 seconds, we're at 150. So at 7 seconds, we'd be at 175. All right, so our volume is 175, right? So volume of the water equals 175. All right, volume total, this is a cylinder, so we have pi r squared h. R is 3, h is 7. So we have 9 times 7 or 63 pi. All right, so that gives me the volume total, and this wants the percent that's filled. So we're going to take our 175 divided by 63 pi. Now, this one they said use 3.14 for pi. So I'm going to go ahead and multiply 63 times 3.14, and that gives me a 197.82. So I have 175 over 197.82. All right, if I take 175 divided by 197.82, I get 0.884646. All right, now this asks for find the percent. It says round your answer to the nearest percent. So if I move that 2 decimal places, I am at 88%, and that would be my final answer on that problem.